Imagine a civilization in Andromeda galaxy 2.5 million light years away. Right now, at this exact moment, they launch an invasion fleet towards Earth. But also right now, at this exact moment, they haven't even decided to invade yet. I may sound counterintuitive, but both these statements are equally valid and are equally true simultaneously. But how is that possible? It sounds like a riddle, but it's a deeply strange consequence of Einstein's theory of relativity, known as Andromeda Paradox. It suggests that the event we consider the future, for some observers, has already happened. And this isn't just a fun theory, it comes directly from the physics that governs our universe and forces us to ask one of the biggest questions imaginable. Is our destiny already written? To unravel this mystery, we first need to investigate our own intuition about time. For most of the human history, we have used a model of universe conceived by Isaac Newton. In Newton's world, time is like a giant universal river, flowing at the same rate for everyone everywhere. It's absolute. My now is your now, and it's the now for some creature in Andromeda galaxy. It's simple, it feels right, but at the start of 20th century, a young patent clerk named Albert Einstein proved that this comfortable idea is completely wrong. Einstein's revolutionary theory of special relativity was built on one wild concept. The speed of light in a vacuum is constant for everyone, no matter how fast they are moving. Let's use one of Einstein's own thought experiments to see why. Imagine you are on a high-speed train with someone standing in the middle of the carriage. At the exact same instant, two bolts of lightning strikes the very front and the very back of the train car. For someone standing on the platform watching the train speed by, the light from both strikes travel at the same distance to their eyes. Since the strikes were simultaneous, the light arrives at the same time. To this stationary observer, the two events were, without a doubt, simultaneous. But what about the person on the train? From their perspective, they are also in the middle of the car, but the train itself is moving toward the light from the front strike and away from the light at the back. Since the speed of light is constant, the light from the front has less distance to cover to reach the person's eye. It arrives first. Light from the back, chasing a moving target, arrives a split second later. For the person on the train, the light did not strike at the same time. The front was hit before the back. So, who's right? The person on the platform or the person on the train? According to Einstein, they both are. There's no such thing as a universal now. The order of events isn't fixed. It's relative to your motion. This is called the relativity of simultaneity. Now it's crucial to understand that this doesn't mean that we can see or causally affect distant events. Causality is preserved. Information cannot travel faster than light. This is purely about how we define the present moment, and it's the key to Andromeda Paradox. For things happening nearby, this difference is imperceptibly small. But when you apply this idea to immense distances between galaxies, the results are staggering. Now let's go to our neighbor, Andromeda, 2.5 million light years away. Light from there takes 2.5 million years to reach us. So when we point our telescope at Andromeda, we're seeing its distant past. What's happening there right now is unseeable. But thanks to relativity, we can calculate what's happening there now. The catch? The answer entirely depends on how you are moving. This is the thought experiment conceived by the brilliant physicist and mathematician Roger Penrose, dubbed the Andromeda Paradox. Imagine two people on Earth, Alice and Bob. Alice is sitting on a bench. Bob starts walking past her. They are in the same place at the same time. But Bob's motion relative to Alice means his personal slice of what he considers now across the universe, his plane of simultaneity, is tilted compared to Alice. Now here on Earth, that tilt is meaningless. It's so microscopic that their nows are virtually identical. But when you extend that tilted plane all the way to Andromeda galaxy, 2.5 million light years, that tiny angle acts like a giant cosmic lever. A walking pace of just few miles per hour is enough to shift your plane of now in Andromeda galaxy by several days. Let's use Penrose's own dramatic example. An alien civilization in Andromeda is debating whether to launch an invasion fleet to Earth. For Alice, sitting on the bench, her now slices through time at a moment when Alien Council is still arguing. For her, the decision is unmade, the future is unwritten. But for Bob, who is simply walking toward Andromeda, his tilted plane now cuts through Andromedan time a full day later. In his version of now, the debate is over. The decision has been made, and the invasion fleet has already launched. For a third person walking away from Andromeda, there now could be a day earlier before the council even convened. This is the core of the paradox. Two people, side by side, can experience completely different realities of what's happening now. For one, an event lies in an uncertain future. For the other, it's a fixed part of their present. So, was the invasion ever truly undecided? If an observer exists for whom the event has already happened, can we really say that the future is open? This isn't about seeing the future or time travel. No information travels faster than light. Alice and Bob must wait 2.5 million years of light from these events to reach them. This is all about how we define the present moment. Relativity tells us that there is no simple universal present. Your now is just one slice of reality out of infinitely many equally valid ones. Take a second and let that sink in. The simple act of walking can change whether an alien invasion has already happened. What does that do to your idea of present, past, and future? It's a question that has kept physicists and philosophers up at night for over a century. Before we explore the wide answers, tell me your first reaction in the comments. Is this just a weird physics trick? Or does it reveal something profound about reality? The Andromeda Paradox isn't just a brain teaser, it's a sledgehammer to our common sense notion of time. It's one of the strongest arguments for the philosophical idea called eternalism, more famously known as the block universe theory. Picture spacetime, the four dimensions of reality, as a giant loaf of bread. Each slice is a snapshot of the entire universe at a single moment. In this view, the past, the present, and the future all exist simultaneously and are equally real. The Big Bang is at the one end of the loaf, and the ultimate fate of the universe is at the other. And everything that has ever happened, is happening, or will happen is already there, laid out in this 4D block. In this model, our consciousness is like a spotlight moving along the loaf, illuminating one slice at a time. This creates an illusion of a flowing present. But what about past and future? They are just as real and solid. They are just waiting for our spotlight to reach them. The block universe neatly solves the Andromeda paradox. If all the moment in time already exist, there is no contradiction. Alice's now is just one slice through the block. Bob's now is slightly different, angled one. The Andromedan invasion is already part of the block, just like your birth. Their disagreement is just how they slice up the same 4D reality. Many physicists lean towards eternalism because it fits so well with Einstein's relativity. But this solution has a heavy philosophical cost: free will. If the future already exists, our choices must be an illusion. The feeling of freely deciding what to do next is just your consciousness experiencing a pre-written script. This means somewhere in the space-time, your death already exists just as concretely as your birth. Does that change how you live today? The outcome is always set in a stone, baked into the fabric of space-time. Means no free will, means no uncertainty. That's a staggering price to pay, as it seems to rob us of our agency. That discomfort has led to other theories of time. One is the growing block universe, a hybrid idea where the past and present are real, but the future is not. The universe is like a block that actively grows as the present moment advances, turning future possibility into fixed past reality. This view preserves our intuition that the future is open. The problem is its incompatibility with relativity. If Bob and Alice disagrees on what now is, the block can't have a single growing edge whose present moment gets to create the reality. Then there is presentism, the theory that feels more natural. It states that only the present moment is real. Past is gone, the future doesn't exist yet. Time truly flows. This view saves free will and an open future. The major problem? It appears to fly directly in the face of modern physics. Special relativity's denial of a single absolute present seems to directly contradict presentism. To make it work, you would have to find a secret privileged now across the universe that we just haven't detected. So where does this leave us? Trapped between our gut feelings about time and mind-bending implications of the best scientific theories, the debate is far from over. Physicists and philosophers are still digging into these questions, now turning to their other great pillar of modern physics, quantum mechanics. Some interpretation of quantum mechanics, with their inherent randomness and uncertainty, seems to clash with predetermined picture of a block universe. Could the quantum world, where the particles exist in a fog of possibility until measured, be a source of a truly open future? Others are searching for a quantum gravity theory to finally unite relativity and quantum mechanics. The hope is that this ultimate theory might reveal the true nature of time, perhaps even revealing a special frame of reference that could salvage a version of presentism. For now, these are open questions at the frontiers of science. But the lesson of the Andromeda galaxy is powerful. It forces us to accept our perception of time as simple flowing river might be a local illusion. It doesn't mean that we can time travel or change the past. Cause and effect are still strictly enforced. You can't be affected by an event until its light can reach you. But the paradox reveals that the very fabric of reality, the definition of existence itself, is far stranger than we can comfortably imagine. It suggests that what we call the future may not be an unformed fog, but a solid, real landscape that's simply waiting for us to arrive. We saw how merely moving can shift your present moment by days in a distant galaxy. This journey led us to the block universe, a chilling but logical version of a pre-written reality where past, present, and the future are one. We explored other ideas like the growing block universe and presentism, each trying to rescue our sense of open future, but each clashing with the power of Einstein's relativity. The Andromeda Paradox doesn't provide easy answers. It doesn't prove that our fate is sealed. What it does is it holds up a mirror to our most basic assumptions and shows us that they might be wrong. It reveals a universe where our intuitive sense of reality shatters over cosmic distances, leaving us with a profound and humbling mystery. So is time a flowing river carrying us into an unknown future? Or is it a frozen block, a four-dimensional landscape we are just discovering one moment at a time? The paradox doesn't give us the final answer, but it makes us ask the question. And in doing so, it reveals a universe that is far stranger, more complex, and more wonderful than we have ever imagined. So what do you think after all that? Do you believe that the future is already written? Let me know your thoughts in the comments. And if your brain is still buzzing from the implications of the Andromeda Paradox, be sure to subscribe and hit that bell for more journey into the deepest mysteries of the cosmos. Thanks for watching.